Imagine analyzing an image. To us, recognizing objects is simple, but to a computer, it's just a grid of numbers, each representing a pixel's color. So, how do we teach a machine to understand what's in the image? This is the role of computer vision. Computer vision is a field of AI that enables machines to interpret visual data. The key technology behind it is convolutional neural networks, CNNs, which mimic how our brain processes images. CNNs analyze pixels in layers, detecting basic features like edges in the first layer and more complex patterns in deeper layers. When a model is trained, it compares its predictions with the correct labels, for example, cat, and calculates the loss. This loss is propagated back through the network using backpropagation, adjusting the weights to reduce error over time. With enough training data, the model learns to generalize, recognizing a cat in various environments, even if the image is rotated, scaled, or has noise. This is why computer vision models get better with more data and training. Beyond classification, object detection identifies not only what objects are in the image, but also where they are, often using algorithms like YOLO or RCNN. This is used in real-time applications like self-driving cars, where models detect pedestrians, traffic signs, and other vehicles. To improve model performance, data augmentation is used. It involves artificially modifying training data, for example, rotating, flipping images, to expose the model to more variations. In summary, computer vision uses CNNs to process images. Through training, feature extraction, and backpropagation, machines learn to recognize objects, understand scenes, and make decisions, revolutionizing fields like autonomous driving and medical imaging. Thanks for watching. Like and subscribe for more on AI and machine learning.